Hello students. Today is the first lecture session, part 2. The topic of the lecture is standards in the field of ICT. In this video, we will cover the following topics. The concept of ICT as an objective standardization. Standardization of ICT at the international and regional levels. Standardization of information security. Conclusion. The concept of ICT as an objective standardization. The main role in the development of the information society belongs to international standards, which are created on the basis of 6 principles defined by the World Trade Organization: openness, transparency, impartiality and compliance with consensus, efficiency and expediency, coherence and focus on development. The general concept. The first steps in the organization of a single information space were taken in the 80s of the last century in the US defense industry in connection with the need to ensure rapid data exchange between the customer, manufacturer and consumer of weapons and military equipment, as well as to improve management efficiency, reduce paper document flow and related costs. Previously, these technologies, the so-called CALS technologies, were introduced only in the military, but having proved its effectiveness, this concept began to spread in industry, construction, transport, covering all stages of the product life cycle from marketing to recycling. Initially, the abbreviation CALS stood for Computer-Aided Logistics Support, computer support for deliveries. With the introduction of this technology in other areas, the abbreviation has been preserved, but its interpretation is broader: continuous acquisition and life cycle support, continuous information support of the product life cycle. Currently, there are 25 national organizations that coordinate CALS technology issues. ISO models. New generations of ICTs include automatic text and speech processing systems, computational and logical and expert systems, intelligent systems for use in management, design, training, and CALS technologies for continuous information support of the product life cycle. When creating integrated systems, the emergence of new generations of technical devices and software, and their Massachusetts production, there is a problem of compatibility, including functional, technical, information and communication tools. This problem is solved by the open systems methodology, which is currently supported by major developers and manufacturers of computer and communication equipment. An open system is a comprehensive and consistent set of ICT standards and functional profile standards that set requirements for interfaces, services, and supporting formats to ensure compatibility and mobility of applications, data and personnel. Example: imagine a certain hierarchy, a model of life, which will also have 5 levels: atoms, molecules, cells, bacteria, people, peoples, communities. Each standard of living performs its functions. Looking under the microscope, we see the lowest level, which in principle can exist without a level above. Data types work the same way. Each of them corresponds to its own level of the model, except for the 5th, it corresponds to 3 at once. The lower layers, 1 through 3, of the OC model control the physical delivery of messages and are referred to as media layers. The upper layers, 4 to 7, of the OC model are designed to provide accurate data delivery between computers on the network and are called host layers. The OC model is not a network implementation scheme, it only defines the functions of each layer. 7 levels of the OC reference model. The OC reference model is a reference model for the interaction of open systems, which is used for communication in various networks. ISO, International Organization for Standardization, has developed this reference model for communication to be followed globally on a given set of platforms. As a software tester, it is important to understand this OC model, since each of the software applications operates on the basis of one of the layers of this model. First, bits the physical layer. Impulses, particles that are transmitted in a physical environment. This is a data transmission medium: Wi-Fi, Raurier pulses, an electrical network of wires, fiber optics, light pulse, etc. Protocols: 802.11, Wi-Fi, GANs-M, E802.15, Bluetooth. Physical layer specifications define characteristics such as voltage levels, time parameters of voltage changes, physical transmission speed, etc. Second, deframes data link layer. Second, deframes data link layer. Impulses from the wire or radio get into the connector channel of the equipment. There they are converted to frames. Their integrity is checked and they can be sent further. Sending goes to the MAC address. Equipment capable of performing such simple operations: switches, bridges, switches. Protocols: Ethernet, ARCnet, ATM. The link layer addresses physical addressing, network topology, error notification, ordered frame delivery, and data flow management. Third, packets network layer. Third, packets network layer. Frames can walk for short distances from one interface, MAC address, to another. In order for information to reach a specific place, it is packed in packages and will walk around the network, passing perhaps dozens of computers, but will get to the right place. The transfer is no longer at the MAC address, but at the IP address. The equipment that can perform these functions is routers. Protocols: IP/IP/IP, IPsec. Network layer: a complex layer that provides connection and route selection between end systems that can be located geographically in different networks. Fourth, segments the transport layer. Fourth, segments the transport layer. Download the movie, which is divided into 1,000,000 packages, all pumped, and one got lost, and all together now do not stick together. To prevent this from happening, at this level, packets are combined into segments and transported in such a way that if any is lost, there is a request to repeat the loss. If there are two identical ones, the unnecessary ones will be deleted. This is how TEC works. UP is faster, but it can lose segments. The transport layer provides mechanisms for setting up, maintaining, and completing virtual channel activities in an orderly manner, detecting and troubleshooting transport failures, and managing information flow. Fifth, session. Fifth, session. We do not need segments, but data, and they will only arrive if you start a session with the server. By selecting Download Movie from the internet, we open a session with the server and it will close automatically after downloading. At this level, synchronization, writes, and sharing are defined. Protocols: ADSP, ASP. The session layer establishes, manages, and terminates application interaction sessions. Sessions include a dialogue between two or more view objects. The session layer synchronizes the dialogue between view-level objects and manages the exchange of information between them. The session layer provides a class of services and reporting tools for reporting special situations. Sixth, executive. Sixth, executive. So we already have data, an incomprehensible file that does nothing. We need to present it somehow. Perhaps compress, or decompress, find an encoding to open, or perhaps a cipher to transmit over the network. It all happens at this level. Protocols: LPP, and the view layer is responsible for ensuring that information sent from the application layer of one system is readable to the application layer of another system. If necessary, the view layer converts data formats by using a common format for presenting information. Seventh, application. Seventh, application level. The level at which we work. The user, in principle, does not need data, he needs his program, application to work. This is the highest level at which the application that is located on the computer will access the network for the necessary data. The application layer is the closest level of the OC model to the user. This layer does not provide services to other layers, but only serves application processes outside the OC model. The application layer identifies and establishes the availability of proposed partners for communication, synchronizes jointly running application programs, and establishes agreements on error recovery procedures and data integrity control. Standardization of ICT. The development and improvement of the base of TAR law, technical regulatory legal acts, in the field of ICT is aimed at achieving the following goals: ensuring increased efficiency, sustainability and efficiency of ICT dissemination in all spheres of society and human activity, creating and maintaining the level of information potential necessary for the sustainable development of society, integration into the global information space, promotion and introduction of advanced domestic and foreign information technologies, development of the primary data communication network. The main objects of ICT standardization are computer equipment and data transmission networks, information support and databases, software, information systems. Standardization of ICT at the international and regional levels. Standardization of ICT at the international level. Standardization of ICT at the international level is carried out by three international organizations: ISO, IEC, ITU. ISO, International Organization for Standardization. IEC, International Electrotechnical Commission. ITU, International Telecommunication Union. One of the most important tasks addressed by these organizations is the elimination of tech barriers to trade, by addressing issues of compatibility of computer equipment, which currently make up more than 50% of products produced by the electrical and electronic industries. The standardization sector of the International Telecommunication Union ITUT specializes in developing recommendations that ensure the interoperability, the ability of a system to interact with other systems, of a communication service on a global scale, a service related to the data transmission of integrated communication services, voice and data, messages and reference information. ISO and IEC, as well as their Joint Technical Committee for Standardization ISO/IEC/JIT, have developed more than international standards covering the following ICT areas: telecommunication and information exchange between systems, software, tools for digital data exchange, identification cards, programming languages, their environment and software interface, compatibility of information technology equipment, computer graphics and image processing, information technology security, automatic data collection, managing data usage, the description of the document and language processing, user interface, etc. International standards form basically an interconnected set of basic standards that define recommended norms, rules and requirements for ICT components and tools. The development of standardization in the field of ICT is significantly influenced by a large international consortia, 150 consortia working in the field of ICT standardization. As a rule, consortia differ in their areas of interest, organizational infrastructure, and financing methods. Some of them are ISIC Internet Society (DAWU), ISIC.org, Association of Experts responsible for the development of Internet technology standards. ITF Internet Engineering Task Force (DAWU), ITF.org, solves current problems in the field of standardization and development of Internet technologies. IRTF Internet Research Task Force (DAWU), IRTF.org, solves problematic problems in the development of Internet technologies. Object Management Group (DAWU)org, an international consortium that develops standards for unified distributed software based on the principles of the object-oriented model. WC, World Wide Web Consortium, DAWU.org, a consortium that specializes in the development of standards for DAWU technologies, such as, for example, AIDS, HTML, URL, XML. ATM Forum, Asynchronous Transfer Mode Forum, DAWU, ATAForum.org, a consortium whose goals are to develop standards for asynchronous broadband networks. ECPS, European Committee for Banking Standards, org, responsible for the development of a pan-European standard for banking infrastructure. DAVIC, Digital Audiovisual Council, DAVIC.org, a consortium that developed architectural, functional and information models and standards for multimedia services of the global information infrastructure. Telemanagement Forum, Forum.org, a global consortium of operators and service providers that develops standards for managing private networks and services. Open Group, Open Group, org, the organization, formed in 1996 as a result of the merger of the X/Open and Open Software Foundation consortia, explores the issues of openness and seamless introduction of information systems into the Internet. Gigabit Ethernet Alliance, Gigabit Ethernet org, a consortium that aims to develop standards for next-generation Ethernet technologies. E802.3Z standard for fiber optic communication systems that provide a data transfer rate of 1 bit/s. Standardization of ICT at the regional level. An alternative to international consortia is the activity of a large number of competing companies, Sun Microsystems, SCO Group, Novell, etc., that produce compatible serial equipment, the standards of which become international, de facto, in international practice one of the forms of recognition, meaning official, but not yet legal recognition. Work on the standardization of ICT is also carried out by industrial professional organizations, among which the Institute of Electrical and Electronics Engineers, should be highlighted. The first standard for software development was created by the EE in 1979. By 1990, ISO/ECJIT 1/I Ferolina 7 had developed 8 standards, 6 are still in force. The EE had already developed 14 software standards, the number of which increased to 27 by 1994, now there are more than 50. Regional level. At the regional level in the UN, coordinating the work of standardization and quality assurance in ICT held by European Committee for Standardization, CEN, European Committee for Standardization in Electrical Engineering, NEL, the European Institute for Standardization in Telecommunications, ET. The European Committee for Standardization, Comet Europe and Denormalization, CEN, is an international non-profit organization whose main goal is to promote trade in goods and services through the development of European standards, Euronorm. The organization was established in 1961. TENELIP was created in 1971 by the union of 2 European organizations, the European Committee for the Coordination of Electrotechnical Standards of the EFTA member states and the European Committee for the Coordination of Electrotechnical Standards of the EU member states. TENELIP members are 17 European countries: Austria, Belgium, Great Britain, Germany, Greece, Denmark, Ireland, Spain, Italy, Luxembourg, the Netherlands, Norway, Portugal, Finland, France, Germany, Switzerland, Sweden. All of them are represented by national electrotechnical committees and are members of the EEC, except Luxembourg. The beginning of the ETSI Institute's activity dates back to 1988. Its main task is to find common standards on the basis of which it is possible to create a comprehensive telecommunication infrastructure. This infrastructure is designed to ensure full compatibility of any equipment and services offered to consumers. In addition to these organizations, specialized regional organizations that have developed more than 600 European standards in the field of ICT are also involved in the work on creating ICT standards. The European Postal and Telegraph Conference CERT was formed in 1959 by 19 countries. Currently it includes 48 member countries, covering almost all of Europe. European Committee for Certification in the Field of Information Technology (ESITS). One of the main trends in the standardization process is the increasingly close integration of the activities of various organizations aimed at creating a unified system of standardization of the information society. The main direction of work on the standardization of ICT in the Republic of Kazakhstan is the use of international achievements and the adoption of international standards as state standards. Standardization of information security. Standardization of ICT at the international level. Security processes superimposed over the software design life cycle. Requirement definition. At the requirement stage, security-specific requirements can be introduced, along with known abuse cases, use cases that an attacker might follow, and a risk analysis. Design and architecture. As candidate architectures become available, reviews must include security aspects that may not have been included previously. At this stage, testing plans should be created that include security analyses that follow the perceived abuse cases. Code development. At the coding stage, following security guidelines and coding standards are critical. The use of automation tools such as static analysis is key to ensure that vulnerabilities are not introduced into the product. Integration and test. As the system as a whole starts to take form, subsystem and system testing will find vulnerabilities before integration and deployment to the market. Deployment and maintenance. When a product enters the market and starts wide deployment, security vulnerabilities become exponentially costlier to fix. As a product goes through maintenance and revision, security is an ongoing concern and new vulnerabilities and threats need to be fed back into the system in an iterative approach. Information security. Information security is the state of security of the information environment of society, ensuring its formation, use and development in the interests of citizens, organizations, and the state. Information protection is an activity to prevent information leakage, unauthorized and unintended impacts on the protected information. It is a process aimed at achieving this state. The CIA model is often used as the standard security model. C. Confidentiality. Information availability only to a certain circle of persons. I. Integrity. Guarantee the existence of information in its original form. A. Availability. Possibility of obtaining information by an authorized user at the right time. To the above, you can add other categories of information security. Authenticity. The ability to identify the author of the information. Appellability. The ability to prove that the author is the declared person and not another. Some statistics explaining its relevance. If a commercial organization leaks more than 20% of important internal information, then in 60 cases out of 100 it will go bankrupt. It is also claimed that 93% of companies that lost access to their own information for more than 10 days left the business, and half of them declared their insolvency immediately. According to statistics from the FBI's National Office of Computer Crimes, 85 to 97% of attacks on corporate networks are not only not stopped, but even not detected. A special group of experts conducted an analysis of the security of military information systems. In 88% of cases, unauthorized access to these systems was successful. Thus, the protection of information in terms of its characteristics and costs should be commensurate with the scale of threats. In addition to subjective safety reasons, there are also technical ones. Due to the peculiarity of the operation of any electronic systems, it is the presence of radiation. For example, an encryption unit sends an encrypted message over a telephone line, and an electrical signal from the original message is transmitted along with it. Therefore, with good hardware, the original message can be restored. The encryption machine, like any other electrical machine, has a side electromagnetic radiation, which is modulated by the information signal even before it is encoded. Thus, by intercepting and analyzing the spurious emissions of the encryption machine, without having a key to decrypt the encoded messages, it is possible to obtain the necessary information. For a long time, everything related to the concept of PEMN, side electromagnetic radiation, was shrouded in secrecy. The first report that appeared in the open press belongs to the Dutch engineer Wim van Eyck, who published in 1985 the article, Electromagnetic Radiation of Video Display Modules, The Risk of Interception. The article is devoted to potential methods of interception of composite signal of video monitors. In March 1985, at the Securicam-85 exhibition in Cannes, Van Eyck demonstrated equipment for intercepting monitor emissions. The experiment showed that interception is possible with the help of a slightly modified conventional television receiver. The pictures show the equipment for intercepting signals. Strategy and effective use of ICT. Standards. The problem of radiation protection led to the creation of the Tempest program in the United States, which developed standards for the electrical radiation of computer systems used in secret organizations. The goal of the program was to reduce the level of radiation that can be used to collect information. In 1983, the US Department of Defense developed the Standard MIL 5200.28 Trusted Computing System Evaluation Criteria criterion for evaluating the security of computer systems. Because of the color of the cover, it was called the Orange Book. This model was based on the government's concept of information classification levels: unclassified, confidential, secret, top secret, and access levels. In Europe, the ITSEC Standard Information Technology Security Evaluation Criterion, Information Technology Security Assessment Criterion, served as a security assessment criterion. ITSEC and its European counterpart ITSEC have been revised, and a new ISO/EEC 15408 safety standard has been developed within the framework of ISO. Its 1999 counterpart is SAINT 3/2004, currently adopted in the new version of 2005 and consisting of 3 parts: ISO/EEC 15408. This standard is known as the Common Criteria for Information Technology Security Evaluation (CITES). The criteria formulated in ITSEC and CITES define the division of computer systems into 4 main security levels: A, B, C, D. Level A is the most highly secure. This is followed by level B, within which classes B3, B2, and B go in order of decreasing security. Then the most common level is C, with classes C2 and C1. The lowest level is D, which includes systems that failed to qualify for the above classes. Level C, random access control. Level B, forced access control. Level A, verifiable security. For each class, the functional and warranty requirements that the system must meet in order to meet a certain level of certification are defined. The main idea of the modern security concept is concentrated in the so-called protection profiles, SP, which define the various security environments in which a computer system can be placed. For example, SP of database management systems, SP of firewalls, SP of operating systems, SP of access control systems. Its security profile is an implementation-independent set of security requirements for a certain category of its products that meets the specific needs of the consumer. The piece does not regulate how these requirements should be met, thereby allowing the developer of the security system to choose the means of protection independently. The AP can be applied either to a specific class of products, such as operating systems or firewalls, or to a set of products that form an information technology system, for example, virtual private networks, PP. The use of security profiles has 3 main objectives: standardization of sets of requirements for information product security, assessment, conducting a comparative analysis of the security levels of various IT products. Currently, more than 20 Ps have been developed. Computer systems are evaluated for compliance with these profiles and certified. When purchasing a system, the organization has the opportunity to choose the profile that most fully meets its needs, and choose equipment that is certified according to this profile. Following a compromise between security requirements, system efficiency, and its price, the vast majority of companies today seek to obtain a C certificate. The security policy and level of guarantee for this class must meet the following critical requirements. Users must identify themselves, and authentication information must be protected from ENS. Hardware or software tools must be available to periodically check the correct functioning of hardware and firmware components of the trusted computing base. Security mechanisms must be tested. There are no ways to circumvent or destroy the security of a trusted computing base. International Information Security Standards. However, computer system technologies are developing too fast compared to the certification program. New versions of operating systems and hardware are emerging and finding their markets even before older versions and systems are certified. During the time it takes for systems to pass certification, they have time to become outdated. Currently, more than 60 international standards have been developed at the international level in the field of information security. International Standards B7799-123-2005-6 ISO/IEC 17799-2005 ISO/IEC 27001 27002 27005 2005 A collection of recommendations for the deployment of an information security management system for employees of organizations responsible for the development, implementation and provision of information security. These fundamental standards form a common basis for the development of security standards for individual organizations, effective rules for maintaining this security and ensuring the confidentiality of trade relations between organizations. At the national level, the above-mentioned international standards come into force after their adoption as national standards. Conclusion. International standards should be implemented for each system component of the network, including each operating system and application packages. As long as the components meet such standards, they meet the goals of open systems. A characteristic feature of modern international and Russian IT standards is that they contain definitions of the main concepts and terms of the IT field, descriptions of models, scenarios, functions, rules of behavior and presentation of information. In other words, the properties of IT/IS systems are presented in the standards in the form of conceptual, functional, and information models of standardization objects. Thank you for your attention. Goodbye.